Welcome to Brain Vision.
In this problem, we have two smooth disks A and B with identical mass which are moving towards each other. They then collide and move off. We have the final direction of disk B, and we hence wish to calculate the coefficient of restitution between the disks after the collision. Now, for disk B, we draw the diagram as follows, and we break up its final velocity VB2 into y and x components. So let's first apply the conservation of momentum. So the momentum of each disk before the collision must equal to the momentum of each disk, the sum of the momentum for each disk after the collision. So let's look at the horizontal direction and take the right as positive. So for disk B, we have its mass, which is 0.5 times 4 cosine theta, which is 4 times 3/5. In the opposite direction, disk A has negative velocity, since it's moving to the left, of 6 meters per second multiplied by its mass of 0.5. And this must equal to the momentum after the collision. So for disk B, this is minus 0.5 times the speed of B in the x direction plus 0.5 times VA in the x direction. So if we simplify this, we get minus 3.6 is equal to minus VB2x, and subscript 2 is for after the collision, plus VA 2x. So here we have an equation with two unknowns, the x component of the final velocity after the collision. Now let's go and look at the vertical components, and we'll take the upward direction as positive. Again, we'll use the conservation of momentum. So in the y direction, for disk B, m times v is 0.5 times 4 times sine theta, which from a diagram we can see is 4/5. And this must equal to the final y component of disk B, 0.5 VB to y, since disk A moves only along the horizontal axis, along the x-axis. So from here, if we rearrange this equation, we can see that after the collision, disk B moves in the y direction with velocity 3.2 meters per second. So that's upward. Now, since we have this, we can find VB2x, which is 3.2 times the tan of 30 degrees. So remember, we have VB2x, and VB2y, and the final velocity of B, VB, and the angle 30 degrees. So we can calculate VB2x using trigonometry, and that's 3.2 tan of 30 degrees, which is 1.8475 meters per second, and that's to the left. The x component of A after the collision, VA2x, is equal to minus 1.752 meters per second. So again, that's to the left, and that's 1.752 meters per second to the left. So now that we've resolved those components, we can go back and look at our coefficient of restitution, again taking the right direction as positive, and calculate E. So E is defined as VA2 minus VB2 over VB1 minus VA1. And since we've calculated all of these, we can find our coefficient of restitution. So we substitute the values we have. It's minus 1.752 minus 1.8475 over the initial velocity of b in the x direction is 4 cosine theta, which is 4 times 3 over 5 minus 6. So we've taken horizontal components, and hence we find the coefficient of restitution E is 0.0113.